today's class, we are initially going to begin with some more points that we discussed earlier. We'll add one or two points to them, and then we'll proceed to our next topic, that is effect of pressure. So the third one is the latent heat of vaporization. In the last class, we discussed latent heat of fusion. In today's class, we'll discuss latent heat of vaporization. Both the definitions are quite similar. Here we were talking about fusion, that is melting, and in vaporization we talk about conversion of liquid into gas. So we define that the amount of heat energy that is required to change one kg of a liquid into a gas at atmospheric pressure at its boiling point is known as the latent heat of vaporization. So like we saw that water at zero has more energy as compared to ice at the same temperature. In a similar way, for vaporization, what happens is steam at 100 degrees centigrade will have more energy as compared to water at 100 degrees centigrade, because water at 100 degrees centigrade gains energy, the energy equal to the latent heat of vaporization, to convert into steam. So steam has more energy, that is why steam is more dangerous to our body. So the fourth one, this might come as a gift reason. Particles in steam have more energy than water at 100 degree centigrade. So particles and steam is also at 100 degree centigrade, has more energy than water at 100 degree centigrade, that is the same temperature. Because particles in steam have absorbed extra energy in the form of heat So what heat, particularly latent heat of vaporization. That is why particles in steam, that is at 100 degrees centigrade, has more energy as compared to water at 100 degrees centigrade, and therefore can become more serious and more dangerous as compared to water at 100 degrees centigrade. Now we come to changing states. So we have three states: solid, liquid, and gas. The conversion from solid to liquid is called melting or fusion, more appropriately, the conversion of liquid to gas is called vaporization. The conversion of gas to liquid back again is called condensation. And the conversion of liquid to solid is called solidification. We also know solidification as freezing. Now, these are some general uses, but there is also one more thing, that solid can convert directly into gas, and this process is called sublimation. And when the reverse of this happens, that gas converting back to solid, it's called deposition. Okay, so we know what melting, solidification, fusion, condensation, vaporization are, but sublimation and deposition is something we might not have heard of. So let's define sublimation. So a change of state directly from solid to gas without changing into liquid state or vice versa is called sublimation. And deposition or desublimation also it's called sometimes. The change of a vapor to its solid state directly is called deposition. Or desublimation. Okay. Some examples of this substances that show sublimation are naphthalene balls. So naphthalene balls, when they are kept, what happens is they convert directly into gas. We can also look at camphor. The kapoor that we use is made up of substance called camphor that converts directly into gas. Then we have another substance called ammonium chloride. Ammonium chloride also directly converts from solid to gaseous in nature. There are some other substances as well, so we stop at this. Okay, now we'll look at one experiment. Say we are taking a stand and in this we have a china dish. On top of a china dish, we have an inverted funnel. So we have a funnel that is inverted over here in a china dish. And say we close the top using a cotton plug. So this is a cotton plug. We have this as our china dish. This is our inverted funnel. And just below this we place our burner. So this is our burner. So what happens is, as this gets heated, so on heating this, we place a small amount of, say, what we are placing over here is ammonium chloride. So as we place ammonium chloride in this china dish, and as we start heating, we see that there is no liquid form of this ammonium chloride. Instead, what we see are vapors of ammonium chloride. So we see vapors of ammonium chloride. So this vapors, as we have closed this by a cotton plug, what happens is this ammonium chloride cannot escape and hence gets solidified in the surface of this inverted funnel. So this is our ammonium chloride which became solidified. Okay, so this is an example of our sublimation. Now we come to the second point. The second point being, so how matter changes its state. The first point was effect of change of temperature. The second point is the effect of change of pressure. Again, we'll look at some diagrams to understand this. Say we have container like this, and we have this container is blocked. Particles inside cannot move. It's stopped by a piston. So we have a piston here, and this is a cylinder. So say we have some particles like this. So what happens is, if we apply pressure, so the piston comes down, so the piston is lower, and these molecules come closer. Now if we apply further more pressure, what happens is this comes more down, and the molecules are much more close to each other. So on application of pressure as well, it has the chances of decreasing. It decreases the interparticular spaces between the molecules. As this decreases the intermolecular particles, the effect of this can be change in state. So as we keep on increasing pressure, what happens is it may convert from gaseous to liquid state. Just like our LPG, the gas cylinders that we used, if you shake it a bit, you will listen to some water splashing around inside the cylinder. Why does that happen? Is because LPG has liquefied petroleum gas. The gas has been put inside the cylinders with so much pressure that they liquefy. So that is why on application of pressure, it has chances of converting them into, if pressure is applied, it may convert from gas to liquid and or liquid to solid also. And on decreasing the pressure, it may convert from solid to liquid, and on further decreasing the pressure, it may convert liquid into gas. Okay, so what is happening here is, by applying pressure, particles of matter can be brought close together. Okay. Okay. One thing to note over here is that, so have you heard of solid carbon dioxide? When we go to some fancy restaurant, many times what happens is, we see that there is a container, and from that container they dip the container in that, and a lot of smoke comes out from the container. So in that, what happens is, a liquid nitrogen is sometimes present, and sometimes even carbon dioxide is present. So it is stored under high pressure. When we increase a lot of pressure on carbon dioxide gas, what happens is, carbon dioxide directly solidifies. It converts from gas directly into solid. So solid carbon dioxide, it is formed when under high pressure solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere. That is why we need to increase the pressure and keep it solidified. So on decreasing the pressure to 1 atmosphere without coming to liquid state. So for this reason, that solid carbon dioxide is also known as dry ice. Okay, so this happens only on application of pressure to our gaseous carbon dioxide. So next topic that we are going to understand is evaporation, and this is a very important topic in our chapter. Evaporation, how does it happen? So in case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break free from the forces of attraction of other particles and gets converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its melting point, below its boiling point, is called evaporation. What happens is the particles in a liquid that are exposed to the surface, in the surface they are in contact with the atmosphere. So from the atmosphere, what they do is they gain heat energy, so they have a higher kinetic energy, the particles that are at the surface. So these particles at the surface having higher kinetic energy are able to break free from the rest of the liquid, that is their own type of particles, and they change into vapors. Even though the temperature has not reached its boiling point, still as they have gained energy from the atmosphere or from the surrounding, they can break free or break away from the other particles' force of attraction. So they convert into vapor, and this process is called evaporation. Evaporation can take place at any temperature. It takes place from the surface of the liquid, and boiling happens to the bulk of the liquid. Whenever we boil a liquid, say we are boiling water, what happens is the whole of water reaches 100 degrees centigrade, and as it boils they convert into steam. So this is a bulk phenomena when we talk about boiling, but evaporation only takes place at the surface of the liquid. Okay, we'll look at some basic difference between evaporation and boiling, because they sound quite similar but actually are very different. So evaporation, boiling. First point, takes place on the surface, takes place throughout the liquid. Second, takes place at all temperatures. Boiling takes place at the boiling point of liquid. Third, in evaporation, as we know, no bubbles are formed. In boiling, bubbles are formed. In evaporation, the energy supplied by the surroundings. So the particles that are at the surface either absorb energy from the surrounding, or they may absorb energy from the liquid itself and from within the liquid. And when we look at boiling, source of energy is required. Whenever say we boil water, we place it above the stove. So we need a source of energy for boiling. So source of energy is required. Number 5th, evaporation. It is a slow process, takes place only at the surface, whereas boiling, the whole bulk of the liquid, whatever we boil, boils together. So it's a fast process. And the last and not the least, it's a very important point, that evaporation helps in cooling, whereas boiling does not. Produces a cooling effect. No cooling effect. We'll talk about this cooling effect in detail after some time. First we'll learn. So this was another important discussion. So next we are going to see the factors that helps in the increase of evaporation. So evaporation increases with, first point is increase of surface area, because it's a surface phenomena. If we have a larger surface, there will be more of evaporation. Second thing, you must have also experienced this when you keep say tea in a glass. So tea in a glass takes some time to cool down, but if you put that same tea from the cup onto a saucer, so since the saucer is like a plate, what happens is it has a large surface area. With large surface area, evaporation happens quickly and it produces a nice cooling effect and temperature comes down. So basically what happens is evaporation increases with increase in surface area. Evaporation also increases with an increase in temperature. Because with increase in temperature, what happens is the kinetic energy that is present in the molecules that are in the surface, their kinetic energy increases. With increasing kinetic energy, they can break away more easily from other particles in the liquid. The third one, a decrease in humidity. Humidity is basically the amount of water vapor that is present in the air. So if the air has a lot of water vapor, if it is very humid, there is an increase in humidity, what happens is water will not tend to evaporate, because diffusion, as we have learned, is the movement of particles from a region of their higher concentration to a region of their lower concentration. So if the air around will have a high concentration of water, so water will not try to diffuse out of the particle of the liquid and come into the air. That is why there should be a decrease in humidity, so that the water vapor is less in the atmosphere, which will favor the increase in the evaporation of the liquid. So a decrease in humidity leads to increase in evaporation. The fourth point, an increase in wind speed. Our clothes, when we leave them to dry, what happens is with increase in air flowing, the clothes will get dry faster. Why does that happen? Is because as the water evaporates, the wind takes away the water vapor away from the clothes. So the there is a vacant space, so humidity is less over there then. So with decrease in humidity, what happens is water tend to lose more water as water vapor, that is evaporation takes place more faster. That is why with an increase in wind speed, evaporation also increases. Okay, now to the last topic, how does evaporation cause cooling? Consider an open vessel. So in an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. So the particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. So as they absorb energy from the surrounding, what happens is it creates the surrounding to be cool. So it makes the surrounding cooler as the energy is absorbed by the liquid. So this absorption of energy from the surroundings make the surroundings cold. Okay, there are many reasons and very many give reasons that can be found. Two important ones. The rest of them you can structure them on your own and try to reason them out. So the first reason that I am going to write over here is why should we wear cotton clothes in summer? So during summer, we perspire more because of the mechanism of our body which keeps us cool. So the particles at the surface of the liquid so as we perspire, as we sweat, what happens is it's a liquid. So that liquid on the surface, what happens is it will gain energy, and that energy as it gains, so what happens is it makes the body cool because energy is absorbed from the body and also from the surrounding, but as the energy is absorbed, it makes us feel cool. So the particles at the surface of the liquid gain energy from the surrounding or body surface and change into vapor. The heat energy equal to the latent heat of, since here liquid is converting into gas, so this is the latent heat of vaporization, is absorbed from the body, leaving the body cool. Now, why is cotton used? Cotton being a good conductor, being a good absorber of water, helps in absorbing sweat and exposing it to the atmosphere for easy evaporation. So if you are getting this for 3 marks, then this much is fine. But if you get it only for 2 marks, then this much writing so much is not required. So what you can do is you can skip this portion from the heat energy equal to this leaving the body cool. You can write till here. So what happens is the surface of the liquid gain energy from the surroundings or body surface and change into vapor, leaving the body cool. So you can skip this portion. I am also including full stop over here because after vapor you need to write leaving the body cool and then the full stop. So if it comes for less marks, you can omit this portion. The second point is, why do we see water droplets on the outer surface of the glass containing ice cold water? So what happens is that the water vapor present in the air, because there is humidity anytime in the air, maybe it's less, maybe it's more, but water vapor is present in the atmosphere. So the water vapor present in air on coming in contact with the cold glass of water, since the water vapor, it needed energy to convert into water vapor, so water vapor has higher energy and the glass of water has less energy. So what happens is energy flows from a hotter object to a colder object. So as it comes in contact with the glass of water, it loses energy and gets converted into liquid state. So which we see as water droplets. So with this we come to the end of this chapter. Thank you.